is talking about section 7.4, which is properties of logarithms in our book. But with what we have been doing this year and dividing our material into units, this is unit 5, lesson 4. So before I actually talk about properties of logarithms, I'm going to kind of review the definition of a log. So if you don't know that already, then this is a good place to get that. Okay, so what we talked about earlier for what the actual definition of a log is. Okay? And the definition of a log, the log base b of x equals y if and only if b to the y equals x. Now when you see that, what we've talked about is this visual here, okay, where you start down here at the bottom and b to the y equals x. That's what that form says right there. So you can always check yourself when you do it. Now, the other thing that I want to point out to you when you look at this, just to help you always check and understand what we're doing, we talked about previously that logs were inverses of exponential functions, okay? But looking at this, okay, what is the log? This is the log. This says the log base b of x equals y. And if you look over here, where do you see y over here? Okay, well, on this side, the log is y, and on this side, y is the exponent. So what I keep saying to y'all is to remember that the log is just a fancy way of saying what's the exponent. Okay, the other thing that I want to point out to you, I'll see if I can get a different color. Let's go with this one. Okay, of my log function, that's my base. And in my exponential function, when I rewrite them and follow this definition, that is the base. So in both of these equations, the base has to be the same. Okay, because it's going to be very, very important for you to be able to go back and forth between these two equations. It's a way of writing things, and if you have a log, how you can get rid of the log by rewriting it in its exponential form. So let's do that with some numbers so you can get some practice with it. What is the logarithmic form of each equation? So I'm going to have a log. Okay, and remember the log is the exponent. So that number over here is going to be the exponent. The base of my log is the same as the base. I was going to write b, the base of my exponent. And so the other number that's left is 36. Now, when you check it, you can just go, oh, did that say 6 to the second equals 36? And that's exactly what that says. So I know that I got that right. So if you have any questions or, pause right now, try to do the next two, and then start back up to check it. So this will be log, my base is 2/3. My exponent is the same thing as the log, so that's the number that goes there, which leaves the last number to be 8/27. You don't have to put parentheses around it, but you can. And again, I'm going to check it and see if that's what the exponential form looked like. And it was 2/3 to the third equals 8/27. So we're good on that one. All right, and then the last one, again, log. My base, excuse me, is 3. My exponent, which is the same thing as my log, is 0, and the number that's left is 3. So check that out, and again, check it. 3 to the 0 is equal to 1, and that's what that says up there. Okay? All right. Now, we have what is the value of the logarithm. So when I did it with 4 classes this year, I asked if they want to see the long way or the short way, and 3 out of the 4 classes didn't want to see the long way. So I'm actually going to talk about this only the short way. If you want to see, I don't really want that color. Well, I like this color better. Um, and that's a really bad line, but it straightened it out for me. So I'm only going to do it the short way, I think, unless I change my mind in the next 2 seconds. Okay, so what you have to do the same process every time, and every time the base of this log is 5. So I have to write this with a base of 5. So that means I'm going to write log base 5, and we had a big sheet, y'all, that we used all the time that had all of our powers on it. So 125 is 5 to the third. Okay? So I write log base 5 of 5 to the third. Well, we just talked about what is a log. A log is the exponent. So that being said, what this is saying, what is the log of 125 if I write it with a base of 5? So I wrote it with a base of 5, and what is the exponent? It is 3. So these are the problems that I referred to in class because I've taught out of a book that called them that. White house problems. What color is a white house? What color is a white house? White. Okay? And so if I say, what's the log base of 5 to the third? The answer is 3. It's right there in front of you. Okay? So the answer is in the question. Okay? So look at this next one. Let's go with log base 4 of 32. So that says log base 4, actually not base 4 of 32, let me start again. Log base 4 of 32. Can I write 32 as a power of 4? I cannot. But can I write them both with the same base? These are both powers of 2. So 4 is 2 squared, and 32, I'm not supposed to write 32. 32 is 2 to the 5th. Okay, so then you're going, oh, the answer is 5, except for there's a little bit difference here. So think back to this one. 5 to the third. What's the exponent on this guy? It's a 1. So if I put the exponents over each other, 3 over 1 is equal to 3. So when they're not the same and you write them with the same base, then it's the exponents on top of each other. And there's a problem I can do at the end that can even show you why that's true if you want to see it. Keep watching. Okay, so on to the next one. What is, hold on one second, please. So we're looking at log base 64 of 1 over 32. So to help you with this one, this is a little bit different. So you need to make sure you remember that log base 64, 1 over 32 is the same as 32 to the negative 1. When we have a negative exponent, that's like 1 over that number. So again, I can't write 32 as a power, or 64 as a power of 32, but I can write them both as a power of 2. And I'm going to show you lots of steps. So 64 is 2 to the 6th, and 32 is 2 to the 5th. When we raise a power to a power, what do I do to those exponents? I hope you said multiply. So that's why this is log base 2 to the 6th of 2 to the negative 5th. So I'm going to put the exponents on top of each other, and my answer will be negative 5 6. So let me go highlight this so you can see what's happening this time. So this exponent here is how I'm getting my answer here. Okay, this exponent here is how I'm getting that answer there. It doesn't matter if you write negative 5 over 6, negative 5 6, however. But as I keep saying, the log is the exponent. So whether you do this the long way, which I don't want to show you, come see me if you want to see it the long way or email me. Um, Either way, both methods, you have to take this expression and write it as the power of that number. So I like to do the short way. It will also help you when you get into other types of problems if you recognize that when you can see the problems. Okay, so now on to properties, which is what the main topic is. Remember that the log is the exponent. So the properties of logarithms or logs are the same as the properties of exponents. Okay, so I'm going to review the properties of exponents. Our product property with exponents tells you that x to the second times x to the third equals x to the, what do I do to the exponents when I multiply? I add them. X to the third over x squared. What do I do to the exponents when I divide? I subtract them, and 3 minus 2 is 1. So, and x to the second to the third. What do I do when I raise a power to a power? I multiply them. So watch how this applies to our logs. Okay, if I'm multiplying logs, then I can rewrite that as adding them. So this becomes the log base b of m plus the log base b of n. So when I'm multiplying, I can remember that that can be broken up into addition. If I have a quotient, then what did I do to these exponents? I hope you said subtraction, which is why this is going to be subtraction. And the power property, most people remember it best by remembering I can take this guy and move it down front, so he becomes n times the log base b of m. And that is multiplying. If I was adding and adding and adding and adding, repeated addition is multiplication. We've talked about that lots before. Okay, so let's see these with actual numbers and how we would do it. So the log of 20, remember if there is no number there, its base is 10. It's called the common log. So the log of 20, 20 can be broken up as 5 times 4. So the log of 20 is the log of 5 times 4. That is a product, and a product can be broken up into two individual logs by saying the log of 5 plus the log of 4. Okay, log base 5 of x to the ninth. This is my power property, and that 9 can be brought down in front to give me 9 times the log base 5 of x. Okay, this one's a little different because we're going the other way. Log base 2 of 24 minus log base 2 of 3. This is subtraction, so I can bring it together with division. Okay, remember that we read from left to right, and we also read top to bottom. So whichever one is first when you're reading left to right is going to be first from top to bottom. So that's going to be log base 2 of 24 divided by 3, and 24 divided by 3 is 8. Now, if you do the short way, then you realize this is log base 2 of 2 to the third, because 8 is 2 to the third, and what's that answer? I hope you already told me that was 3. So that's how that would. They're using properties, but I want you to be able to recognize that. That's going to help you a lot with logs. Okay, log base 3 of 5x to the fourth. This is a product. The first factor is 5, and the second factor is x to the fourth. Put an arrow on that so you can tell what I'm doing. So it's the log base 3 of 5 plus the log base 3 of x to the fourth, and the log base 3 of 5, and we can't leave an exponent when we expand it, so that 4 actually has to come down in front. Okay? And just to contrast this, okay, you could have a different problem, okay? And some people are like, why can't I take that 4 down front first? If it looked like this, 5x to the fourth, okay, then you would bring the 4 down first because it applies to the whole argument is what I call that thing. This thing right here that you're taking the log of is called the argument. And then that would become 4 times the log base 3 of 5 plus log base 3 of x. And you would want to get rid of parentheses, so it would be 4 log base 3 of 5 plus 4 log base 3 of x. And that would be the final answer of using your properties. Okay, so let's look at some real hardcore examples of that. So keep in mind, if it says write as a single logarithm, okay, single, how many are in single? 1. That means your answer should only have the word log in it one time, okay? So we're using more properties, and that says to, I'm adding two logs together. So log base 4 of 5x plus log base 4 of 3x. Okay, if it's adding, then that's what I get when I multiply. So I bring them together by multiplying my two arguments, 5x times 3x. And you, of course, would simplify that to get 15x squared. So that's how that simplifies. Okay, look at our next one. You can't bring them together to addition to multiplication or subtraction to division unless it just says log and log. So if you have a number like this in front, you have to move it to be your exponent first. So our next step here would be the log base 4 of 6 squared minus log base 4 of 9. So now I just have a log and a log, and I can bring those together with division. The 9 goes on the bottom, 6 squared is 36. So I'm going to keep going because that's log base 4 of 36 divided by 9, which is 4. And you see log base 4 of 4, you need to be thinking that's 1. Okay? And those two numbers are the same. That exponent is a 1. Your answer is a 1. Okay? All right, let's go the other way. What is each one expanded? Okay? So when you expand it, what I'm doing here is what we just did here, but we're going backwards. So you're trying to get to something like this in each of these. Okay? So let's look at that first one. Log base 3 of 250 over 37. So that's division, which means I'm going to break it up using subtraction. So that's the log base 250, log base 3 of 250 minus log base 3 of 37. Okay? And that being said, you can stop if your number's prime. Remember, prime is a number that has exactly two factors, 1 and the number itself. So this number is prime, but that number's not prime. So I got to go break it up. And the smallest prime that we have is 2. And 2 goes into 150, 125. Basically, you're trying to break it down to prime. So 125 we already discussed earlier was 5 to the third. So this is going to be the log base 3 of 2 times 5 to the third minus log base 3 of 37. Okay, that's a product, so I'm going to break up my product to log base 3 of 2 plus log base 3 of 5 cubed minus log base 3 of 37. Okay, so the last thing you do, so you can't leave a number that's not a prime number, but you also can't leave an exponent. So the last thing I have to do is just move that down. Log base 3 of 2 plus log base, I didn't bring it down. The 3 times log base 3 of 5 minus log base 3 of 37. So that's how that one expands, making it bigger. Okay, let's look at this last one. Log of 3 of 9x to the fifth. So I am multiplying, so I break it up with addition. Log base 3 of 9 plus log base 3 of x to the fifth. So this is, if you're doing the way I've been telling you, then you should see and know that 9 is a power of 3. So that means this guy is log base 3 of 3 squared. Can't leave the 5 there, so I got to move him down front with my power rule. That becomes 5 log base 3 of x. And what's the log base 3 of 3 squared? Okay, I'm going to say White House because that's the answer right there. The answer is right there in front of you. So this becomes 2 plus 5 log base 3 of x. Okay, so the last thing I'm going to talk about this is the change of base formula. It is another property, again, very helpful. It's what's going to allow you to use your calculator, but unless I tell you to use the change of base formula, you won't use your calculator to ever evaluate logs. So be careful and make sure that you still show work. You can show work on these every time you do them. So log base b of m. Okay, um, I didn't write it like this in class because I didn't want to confuse you too much, but I'm going to tell you it's the log of m over the log of b. Now, there's a c in there also because it doesn't matter which base you use it in. You can do any base that you want to. Now, what base do you want to use on your calculator? You want to use base 10 because that's what your calculator has, but you don't have to use base 10. But more importantly, when you look at, remember this change of base rule, look at these two. Which one is lower down is the B, and he's the one that's going to go on the bottom. The M is on top, he's going to go on top. He's higher up. So when you look at your examples here, log base 5 of 100 is the log of 100 over the log of 5. Okay? Log base 2 of 100 is the log base 5 of 100 over the log base 5 of 2. So these are basically very similar, but this is just showing you that it doesn't matter what base I convert it to. Here I converted it with base 5. Here I converted it with base 10. Okay, and going backwards, if I have the log base 2 of 100 over the log base 2 of 3, then I have 100 on the top, and hopefully you said we have a 3 on bottom. Okay, so look at these last two problems that I have. You just use the change of base formula. What's the value of each expression? Okay, um, I kind of want to start with this second one. Okay, because the second one, if I just use the change of base formula, when you do that, you're looking at it, and the reason you need this change of base formula is because there's no way to write these two with the same base. So I'm going to go use my calculator and say it's the log of 18 over the log of 4. And when I put that in my calculator, okay, 2.085, okay? If you're using an Inspire calculator when you put that, okay, to just get log, just don't put a base in. If you don't put a number in there, it'll do it. And in test mode, you won't have that option. So you need to make sure you know how to do that. Okay, back over on this problem. It's kind of, I'm showing you why this is what I did in the very beginning. Okay, back on the previous page, when I did this problem, you lost my pen. I did it like this. I said, oh, 8 can be written as a power of 2, and 32 can be written as a power of 2. So I knew that it was just 5 over 3. Okay, well, here comes an explanation of why it is. Okay, um, if I did log, this would be one where you would put it in that base you want to because you could still do the change of base formula to evaluate it. Log base 2 of 32 over log base 2 of 8. Okay, and we just discussed log base 2 of 32 is 2 to the 5th over, make that a little bit longer so you can see the steps in between, over log base 2 of 2 to the 3rd. Well, we've talked about this. Log base 2 of 2 to the 5th is 5. Log base 2 of 2 to the 3rd is 3. So here I am getting that answer. Okay, but that's a long explanation of why this is how you can do that problem. Okay, and of course, to verify it, if you need to, that's the same as the log of 32 over the log of 8, which again on your calculator is going to give you 1.66, to 7, which of course is the same thing as that. So all of these are bringing us to the same answer. Okay, three different ways of doing it. When you have to do it by hand, I happen to think that's the easiest. Okay, when you do it on a quiz or show your work for me in your homework, you need to show me this step because I need to make sure that you know how you're getting from one to the next. Okay, 22.5. That is where we have stopped right here, 22 minutes, whatever, zero point 0.5 seconds. Um, Stop, you're done right now. What I'm going to do from here on is to do some even problems from the homework so that if you want some more to look at, you can look at it. So if you're done, you can stop. Okay, so we're going to work some problems together. I'm going to do several of each type, and hopefully that will help you understand this better. Okay, so first off, write each write each equation in logarithmic form. So the key thing that you're needing to use here, okay, log base b of x equals y if and only if b to the y equals x. Okay, that's what I'm using, and I'm doing my little circle thing that we've talked about. So you have this to that. My thing won't write. There we go. B to the y equals x, which is how I'm getting here. So if I'm writing it in logarithmic form, I'm starting here and I'm going this way. When I go down here, I'm starting at this one and going that way. So you got to be able to know how to go both ways. So when I write those first ones, okay, let's go with 49 equals 7 squared. So if I have to write it in logarithmic form, I need a log. I told you the base was the same number, and the log is the exponent, leaving this to be 49. And I check it. 7 to the second equals 49, and that's what it says. Okay? Let's go do this one, because it looks like it could be challenging. So if I come over here and do it, then I'm going to write log base. What is my base? My base is 1/3. Okay? My exponent is the same thing as my log, and that leaves that to be 1 over 27. And just for clarity, you can put it like that. And again, 1/3 to the third equals 1 over 27. So this is an easy one to check. Okay, evaluate each log. So if I ask you to evaluate the log, then you're going to be able to use the powers to evaluate that log. You are not going to need a calculator, so make sure you know that. So log base 2 of 16 is the log base 2 of 2 to the fourth. So what's my answer? 4, because it's 4 over 1. All right. Log base 2 of 8 is going to be log base 2 of 2 to the third. I don't have enough room to do this. And that, of course, is going to be 3. Log base 2 of 2 to the fifth. Wow, I'm sure y'all wish every problem could be like that because that's just 5. There's no work involved. I mean, I've done it for you. That's what color is the White House because it's right there in front of you. Okay? Log base, what am I? Log base 8 of 8. Well, again, those two are the same. The answer is going to be 1. Log base 5 of negative 25. Negative 25. Okay, that's a challenging one. Can I take the log of a negative number? Ooh, I cannot. So this one would be undefined. Okay? Cannot take the log of a negative number. They're kind of tricky. I probably won't do that to you. Okay, but it's a nice thing to know because we've talked about domain and range a lot, and that cannot never be negative. Okay, look at this last one. We have log, there's no base, but you got to remember that the base, of course, is 10, so this would be log base 10 of 10 to the 1, 2, 3, 4. So my answer is going to be 4. Okay, next, write each equation in exponential form. So now, this first one, you were given the exponential, you had to give me logarithmic. Now I'm giving you logarithmic, and you got to give me exponential. So these are the kind I think most people would really love to have all the time. That's just that to that. So 2 to the 7th equals 128. Boom. Okay? 7 to the 5th equals 16807. And of course, you can check that in your calculator if you need to. Okay? 6 to the first is equal to 6, okay? But more importantly, y'all, none of these problems require a calculator unless you can't get the powers. But especially on this first group and this group, it's just rewriting the numbers and making sure you know how to rewrite those numbers. This is going to be 3 to the negative 2 equals 1/9. Again, just rewriting the numbers in the problem and putting them into a different form. All right, so this last group, find the inverse of the function. So I did talk about that in the notes, but the key things that you do want to remember are the directions to that. And whenever you're finding the inverse, you're going to switch x and y, whether you do that graphically or algebraically, and then solve for y. So if I do 62, okay, 62 is going to be, I'm going to switch the x and the y, so that's going to be x equals log 0.5 of y. Now, to go to that other form, I find it easier to put the log on this side, so I'm going to say log 0.5 of y equals x. And to get rid of that log, that's why we need that exponential function. So I have to go and do that, use my definition. So it's going to say 0.5 to the x equals y. So I switched the x and the y, and then I solved it for y. So I'm good. All right, how about, I'm going to do 68, because I know you have one like that for homework. So if I switch my x and y, and I'm going to switch sides at the same time here, so I'm going to put the log of y minus 6 is equal to x. Okay, now what am I doing? I already switched, so I switched my x and y, and I switched the sides. Okay, so now I've got to get rid of that log, and I do that by remembering that this base is 10, and I'm going to raise 10 to the x is equal to y minus 6. I got to solve for y, So I'm going to solve for y by adding 6 to both sides. So 10 to the x plus 6 equals y. And that would be the inverse. Okay, let's look at the next set of problems that we have. Write each expression as a single logarithm. So I'm trying to bring it back together to one log. So when I look at that, this is a log minus a log, and I bring those together with division. So this is the log base 2 of 9 over 3. And 9 divided by 3 is 3, so it's just going to become the log base 2 of 3, and that's all it is. Okay, let's look at 12. Before I do anything with it, y'all, I got to bring this 2 up because I can't have any kind of thing in front of it when I bring those logs. So that's going to have log of 8 minus log of 6 squared plus the log of 3. Um, I'm going to stop because I'm going to tell you something that's a little bit different. When you have a bunch of them, I find it easier to bring them back together. If your log is positive, then it will be, if they're all positive, it's all multiplication. But when you have positive and negative in the same expression, it can be confusing. So when you do that, if you will always know that any positive one is going to be on the top and any negative one will be on the bottom. When you bring this together, okay, this one I hope you realize is positive, this one is negative, and this one is positive. So if I have any negatives, then I have to have division. So on top is going to be 8 times 3, and on bottom is going to be 6 squared. So when I bring those together, you need to figure out what 8 times 3 is 24, and 24 over 36 simplifies to 2 over 3. I find that a little bit easier to deal with. Look at 14. 14 says log of 5 minus k log of 2. Again, got to bring that k up here. I'm going to go up here and do it. So that's going to be log of 5 minus log of 2 to the k. It's subtraction, so I'm going to bring them together with division. So that's going to be the log of 5 over 2 to the k. Okay, make sure that your exponent is clearly looks like an exponent. Okay, all right, when I look at 16, um, I have multiple ones, so I'm going to go through. Do I have anything that needs to be an exponent? I don't, but this one's positive, and this one's negative. So when I write it, okay, if I have a negative, I'm going to have division. Positive ones go on top, negative ones go on bottom. So I'm fine if that's the work that you show me if you're watching this. Okay, expanding, we can do the same thing, okay? Um, going that way, log of x to the third plus y to the fifth, okay? It is a product, so that's going to be the log of x to the third plus the log of y to the fifth. And those come down to be, my powers become my numbers in front. So I'm going to have 3 log x plus 5 log y. Kind of have too much squeezed in here. Okay, I'm looking at this one, and we need to make, I want to make sure I talk about that because that looks, you're going to see it a lot. Okay, so this one, again, is a product, so it's going to be plus, but what you have to remember is that x, the square root of x, is the same thing as x to the 1/2. Okay, that's something, a previous unit that we have discussed. So this is going to be log base 4 of 5 plus log base 4 of x to the 1/2. And I can't leave it, I can't leave any exponents on here, so I'm going to end up with log base 4 of 5 plus 1/2 log base 4 of x. And that's my final answer. Okay. Um, I didn't have a minus. Let's go do 28, then I'll stop with these and do a different type. So 28 is going to look like this. Log base 5, that'll look like a 5, of 25 minus log base 5 of x. Well, I hope you're all thinking to yourself 25 is a power of 5, so this is log base 5 of 5 squared minus log base 5 of x. So this, of course, is my White House, and that's 2 minus log base 5 of x. So that's what that becomes. Okay? All right. I need to pause. I got a class. I'll finish up and do some examples of the rest of those problems. Okay, so let's finish up the last couple of problems here. Change a base formula to evaluate each expression. Just again to do one of those so you can remember looking at 32 here. Okay, I've talked to you about whatever is on the higher number is going to be on top and the lower number is going to be on bottom. Okay, so you put that in your calculator and you're going to get an answer of about let's go with 1.748. Okay, so if you have any trouble with your calculator, don't get that, come see me. Um, okay, use properties of logs to evaluate each expression. Okay, so looking at number 40, let's go. There's nothing in front of it. It's just a log minus a log. It's subtraction, which means I can combine them by making it division. So it would be the log base 2 of 96 over 3. And 96 divided by 3 is, that's going to be, I'm going to come over this way, log base 2 of 32. And we've done log base 2. 32 is 2 to the 5th. And there's my White House. When these two numbers are the same, that odd man out is my answer, so that's going to be 5. Okay, I'm going to go to this one because I don't want to make it too long. We have 1/2 log of 15, log base 5 of 15 minus log base 5 of the square root of 75. So remember that this is my exponent. And remember that 15 to the 1/2 is the same thing as the square root of 15. So when I bring these together, log base 5, subtraction is division. And on the top, I have the square root of 15. And on the bottom, I have the square root of 75. So when I simplify that, it becomes log base 5 of the square root of 1 over 5. Okay, that is, now I'm going to put that square root back to a fraction because that's going to be the log base 5 of, remember 1/5, we've talked about this, 1/5 is 5 to the negative 1, and the square root is 1/2. So this really becomes, I'm just writing down all the steps, y'all, so that you can see it. So that's going to be 5 to the negative 1/2, which means my final answer will be negative 1/2. Okay? All right, moving on. We got um, 56. I'm going to skip those because they don't, I mean, the ones that you have to do are specific to what it is. Although I do want to point this one out right here. Um, Remember, this is an example of our change of base formula. So this actually becomes log base 2 of x. And log base 2 of x doesn't equal that thing. So that's clearly false. Okay, write each expression as a single logarithm. So I'm bringing them back. Okay, and this might be easier. If I see the same number, 1/4 and 1/4 on these, then I know that this is going to be 1/4. That's supposed to be a 4. Let's try that again. 1/4 times the log base 3 of 2 plus the log base 3 of x. Okay. If I'm adding, I bring it together with multiplication. So that's 1/4 times the log base 3 of 2x. Now, this is what I'm taking the log of. So when I take this back to make it my exponent, that whole thing is raised to the 1/4. And when you raise it to the 1/4 power, That's like saying the fourth root. So it would look like this. Okay. Okay. And here's another one. I want to do this one because I want to show you. You can go through all the different steps, but this is like what I told you up at the top. Look at this one. This particular log is positive, this particular log is positive, and this log is negative. And so if I have any that are negative, that means I'm going to have some kind of division. So I'm going to say log base 4. I have some kind of division. This is going to be an exponent. This is going to be an exponent. And that one doesn't have an exponent. So on the top, I'm going to have m to the x and n to the 1 over y. And that's not a y. Hold on. Try to write that again. M to the x, n to the 1 over y, and then a p on the bottom. hmm So that's what that is. And that's enough work for me for you to go from here to here. If you want to write out more steps or have questions about it, then come see me. Okay, on to number 60. So when you get to 60, again, let's go here. That's square root, so you kind of got to go back and forth with those rational exponents that we've done before. So this becomes the log of 2x over y to the 1/2, and that means that can come down front. So that's going to be 1/2 times all of this. Now I'm going to break this up just like I did here. If it's on the top, I'm going to make it positive, so it's going to be the log of 2 multiplication plus the log of x minus the log of y. So I just have to distribute that because I can't have the parentheses. So it becomes 1/2 log of 2 plus 1/2 log of x minus 1/2 log of y. All right, one last problem because I don't want you to stop watching. Write each log as a quotient of two common logs. Same thing we've been doing. So 68, if it says log base 7 of 2, what have we been doing so far? That means it's log of 2 over log of 7. They just didn't want you to simplify the quotient, so that's all that you had to do. Okay? So come see me if you have any questions. Email me or come see me, and I hope that that help you with your practice.